Thanks, Eleanor. Yeah, so as Eleanor mentioned, Sean and I are here today to talk about the all-new Iris MX. So those of you who are familiar with the Iris MX, that's our high-speed camera option for the Motion Amplification platform, and we've just recently launched the new version of that. And you can the title there has the theme data collection just got a whole lot faster. And so the Iris MX is sort of built on a high-speed camera, but there's an all-around speed up, not just with the camera itself, but the workflow that we're really excited about to talk about how this new MX has a lot more capability, and we think it's going to be a really exciting product to get in customers' hands. So we'll do some quick introductions here. I'll go ahead and introduce myself. For those of you who don't know me, I'm the CEO of RDI Technologies. I founded the company in 2013, and originally background in astronomy, physics and astronomy. But always worked in optical physics, and always had an interest in photography. So that's where a lot of the things came together for the technology that we use today. And that research turned to applied research, where we started looking at things as opposed to just really direct R&D research and sort of looking at applications for the technology as we started to learn more and more about how we could measure things. So I'll let Sean introduce himself here.
Hi, nice to meet you all. My name is Sean Hollins. I'm also a physicist and went to a theoretical school and sort of bucked the system and was more interested in applied physics myself. Spent a lot of time in my schooling looking at acoustics and translated that into a career in NVH. Of course, I met Jeff just earlier this year. I got really excited actually to see what RDI brings to the table and the capabilities of what we can do with cameras in the NVH space, the PDM space, and a lot of other markets we're looking at. And then the new MX that we're going to bring to you today really makes that a lot easier, a lot more useful and faster. And this also stems, like Jeff, I share interest in optical technologies and techniques, including photography, music, and excited to help bring RDI into some new markets and new spaces, as well as continuing to strengthen where we currently do really well. So thank you, Jeff.
Yeah, so just real quick, we'll do some housekeeping items, to start out. One thing that we always play videos in our webinars. So one thing to note is sometimes, depending on people's individual internet connections, the videos don't stream the same. But one thing that we do is we load up the video of the webinar to the cloud, and so you'll be getting a link shortly after the end of the webinar where you can download and rewatch this. And so that's true of all of our webinars. We load them up, and so I always want to point out that there's availability of those webinars on our website. So if you go to the remote education site here, let's see, I can bring up our website here, and then let's see, kind of show you, navigate to that. If I can spell it right. Okay, here we go. Yeah, sorry. The browser kind of lost it there for a minute. So if you go to our resources, you can go and you can see there's a section here for webinars. So if you click on that, you can see the upcoming webinar here that we're doing today. We also have another webinar that I think you'll be interested as we go through this. I think you'll gain some interest in this one, in learning more about our high-speed cameras, the HSI cameras. That's going to be tomorrow. And so I would encourage you to join that if you can. A lot of good information there. But also you can see that we have webinars on demand. So if there's, a particular area that you're interested in or just learning about the technology in general, you can go to industry specific webinars. You can look at case studies, look at some customer webinars. Sort of depends on what your interests are. Or there's some more advanced webinars on the technology. So I always encourage you to check that out. And then, as I mentioned, tomorrow, Tom Bolt, who heads up our high-speed cameras, he'll be presenting the HSI camera. So there's two variants of that, and learn a lot more about how those work and how to utilize the high-speed aspect of some of our cameras. And then finally, just want to put a plug in for our Leading Reliability Conference that we'll be doing next May. Some of you may have attended in the past. These are always a really nice conference. In a lot of ways, it is more like a user group meeting. We do workshops at the beginning. We do an advanced training workshop at the beginning. We put this on with Acquam, UE, Eruditio, and FLIR. FLIR is going to be our new partner this year. And so it's a really nice conference in Clearwater, Florida. I think there's a lot of mingling going on. You have a lot of access to the presenters, the other hosts, and as well as the other attendees. So it's a good way to connect and learn a lot about the technologies, as well as just learn what other people are doing in reliability. So again, that's May 13th through 15th, and we always wrap that up with a beach barbecue the last night. So it's a lot of fun. Okay, so a little bit about today's agenda. We're going to do a quick introduction, take you through just a few slides on motion amplification, and then we'll get straight into the Iris MX. We'll give a couple video examples of the MX in action, and then take some questions afterwards. So let me just go ahead and do a little bit of overview before I hand it over to Sean to talk about the new Iris MX. So motion amplification, for if there's anyone on here that's unfamiliar, is a video technique where we can take the video and turn every pixel into a displacement sensor. And beyond that, we can actually measure the displacement per pixel. And then once we can measure it and quantify it, we can increase the visibility of it in the video so that you can actually see it with your eye. So we can visualize motion across the entire scene and turn millions of pixels into millions of displacement sensors, doing full field vibration across the entire video scene. And what's interesting about it, and part of why we're here today, is that the sample rate of the camera, the frame rate, becomes the sample rate of the sensor, in that it determines what frequencies you can see. So naturally, if you want to be able to see higher frequency content, you would need a higher speed camera. And this is an example of the MX looking at 1300 hertz on a glockenspiel, key vibrating. So that's not only happening at very small motions, but it's happening at a rate that we have to have the camera fast enough to be able to see it. Another example here is a wine glass that's 786 hertz. So that's the breathing mode. That's essentially producing the sound that you hear when you tap a glass. If you're at a wedding, you're going to give a toast, or you kind of ding it with your silverware. That is actually what it's doing 700 times per second. And our MX camera can show you that. This is a little bit more, I think, demonstrative of what we're here for, which is the sort of, predictive maintenance, condition monitoring, maintenance and reliability, fixing assets, troubleshooting, and understanding. And so I think what you're going to see today is that the MX is going to make this a lot easier for you and give you all the advantage of a high-speed camera. But I think we're unlocking, sort of a new workflow so that you can collect this sort of data and troubleshoot your assets in a much more timely and faster way. So with that, I'm going to turn it over to Sean, and we're going to start exploring the new Iris MX.
Thank you, Jeff. So what is the new Iris MX? So we've replaced the previous generation Iris MX to really improve portability and allowing faster workflow. So the whole idea with the new camera is to make it easier for you to use in a daily operation. So whether that's carrying it around a plant or doing measurements in a lab, it's fast, it's portable, and it doesn't require a lot of ancillary equipment. I mean, it does include all the same features and capabilities of the previous version. So if you had a standard workflow or there was a way we're using the system, you don't have to change, but it also allows you to replace some of those features and not have to do some of the things you had to do in the past. So it also has been upgraded hardware-wise so that the download speeds are faster. So when you take high-speed video, of course, the files can get large, and we've added a Thunderbolt capability to the system, as well as a way of writing directly to external SSDs to really rapidly get data off of the camera, which, as you take data, allows it to happen much faster. And of course, at the same time, we've upgraded the memory in the camera, allowing for longer record times and more use cases. And the next couple slides will give you some more details on how this works. Oh, and lastly, of course, I shouldn't even say lastly, there's a bunch of other things, but there's new triggering options. And we have some demonstrations of those later on. We can use video as well as electronic triggers to trigger the system. So what does the improved portability look like? You can see the picture on the right-hand side. Gentleman's holding a tablet and then just a camera on the tripod. And this is what we're capable of using now for doing acquisition. So you no longer need to actually bring a full-on computer with you and cabling and connections, but can actually carry the camera, set down the tripod, use the tablet to trigger a measurement, maybe take another view, trigger another measurement, and then go back to your desk and do all the analysis you'd like. So you really just have to carry the camera when you walk around. The camera can record directly to the camera's SSD. So again, you can have long record times if you needed, or a bunch of short files. So you could walk around and record maybe 30 assets or 30 different measurements and save them all there. The saving is instantaneous, happens as you look at the data and hit go, and it's super portable. And the beauty of it is of course you can download the data afterwards for analysis. So instead of worrying about setup in one location, you can set up in multiple locations, take multiple videos, and then go back and analyze the ones you'd like to. So it's a lot easier in the workflow for portability. So what does it look like? Here you can see a close-up of the camera with the top mount handle. And of course, the top mount handle allows you to pick up the camera and the tripod all in one to carry it around. So it's a one-hand operation. This tablet, of course, connects using Fast Motion software, which is part of the FastTech camera suite that allows you to actually control the acquisition, grab data and interface with the system. And of course, there's a battery pack not pictured here, but that goes onto the back, so you don't even have to plug it in. It allows you to actually just go ahead and record video, and the battery is hot swappable. So even if it's a long record time or something else, you don't have to lose out in the file. So a little bit on how it's faster. So there's a couple ways it's faster. Well, one of them is setup, of course, as we described with a portability kit. You can walk around very easily and just take data and analyze it later. But it also is a very high frame rate camera. So it gives you some numbers below. So all the way up in 4K, 5K, it'll do 250 frames per second, or down at 1280 by 720, 1400 frames per second. And we can even go faster if we reduce the resolution. The download speed is over 5 times faster. I know many of you have experienced the previous MX where maybe you wait for a file. We've definitely sped up the whole process of acquiring data. And for those that use an Iris M mostly during the day, if you think of the files you would acquire with the M, if you acquire those with the MX, it now takes less than 15 seconds over Ethernet in RDI acquisition to download those files. So it's nearly instantaneous, even with large video files. And if you like and want to do it in another way with an external drive using the Thunderbolt, we can transfer files at a much faster speed because of the Thunderbolt connection. And again, the beauty is you don't have to carry the PC and your full kit for acquisition. You can actually walk around with just the camera. And want to make sure that everyone realizes too, there's no functionality change or loss with the new MX. We made sure to make it completely backwards compatible in how the operation is. So all the functions that you had before within RDI acquisition are there, which means you can keep any previous workflow you like. The training's still valid, but the new camera workflow will allow simplifying that setup. And so with a little more training, we can show you how to utilize that camera, carry it around, and actually just acquire the data for post-analysis.
And then, Sean, I can kind of demonstrate a little bit of that. I'll bring up RDI acquisition here, and then we'll kind of bring up the camera. Let's see here. Okay, so this is so here's the acquisition software. You can see, the MX is loaded up just like normal. And you can, sort of take a data collection here, just like normal. So the same workflow that is sort of capable of running with the new MX. It's plug and play, just like before. One of the things I think Sean had pointed out, that if you were to take an acquisition, just like the Iris M workflow. So I think a lot of people think that that the MX is sort of reserved for high speed, but I think with this new workflow in collecting data sort of at the same resolution, the same frame rate, 120 frames per second, 3 seconds, 1920 by 1080, all standard Iris M workflow settings. Now you can record that and then save that, and that speed is really fast. So if you think about this would be like taking a data collection from an Iris M. So the idea that with all these improvements with the MX and increasing the workflow, you can now think, well, I can take this out instead of the Iris M if I choose to, because the speed up has allowed you to operate in what probably is an overall faster workflow. So I just wanted to point that out, and then I'll turn it back over to you, Sean.
Some technical details. The portability kit includes the handle, wireless or tethered camera control. So you saw in the picture before a little Windows tablet that was being carried around that allows you to do the acquisition. You could have it be wired or wireless, both work. So it could be wired like Jeff showed with the example of mimicking the Iris M, but also wireless if you just want to record data remotely. And it includes the battery pack as well. Some other improvements, we've gone from 8 gigabytes of data, or excuse me, of RAM in the old MX to 32 gigabytes, which allows a lot more, a larger data size inside RAM itself for high-speed capture. And of course, there's also 1 terabyte SSD. So again, more storage, so you could take more data. So if you wanted to do a complete route or measure a lot of different objects, that can all store in the camera in one shot. And there's also a video-based trigger with microsecond precision, including pre-triggering. So if you wanted to actually not miss anything you were truly measuring, but you wanted actually something in the video to start the measurement instead of a mechanical start, that's possible now as well. And intrinsically, the camera stores directly to an RDI file format, whether you're using the RDI acquisition or the FastTech acquisition for remote operation. So there's also some extended input and output ports allowing flexibility. So if you wanted to trigger on a TTL or a data input, you surely can. We also have trigger outs for when the camera starts, so you could actually start or let something know that acquisition's happening. There's also a sync for multiple cameras. So if you want to sync 2 cameras from 2 different angles on the same machine or 2 different views, the MX does allow for that now as well. And you can instantaneously save on an external drive. So on one of the connections on the side that you can see is a Thunderbolt connection that allows you to connect to an external hard drive if you like, or another storage device or your computer, and actually download data straight to it. And you'll also see a little Wi-Fi symbol on the camera. that allows for the tablet to do all the control and interact with the camera to a tablet or any other computer that you'd like to use as a wireless control for the camera. For applications where Wi-Fi is not allowed, it is completely removable. So we do have a secure version without Wi-Fi, in which case you'd have to use a wired connection. Both are available. Wi-Fi is standard. So it's a very touch-friendly UI as well too. So in order to make sure that as you go on a route or travel with the camera, that it's easy to acquire data, we worked hard to make sure that there's an interface that allows you to just touch and hit record via a handheld tablet. So you don't need a keyboard or a mouse to come along with you. And this allows you to remotely start an acquisition, which could mean that you could put your camera right next to an asset behind a safety curtain in an area that's dangerous for you, but you could put the camera and still remotely control that with the tablet. So it allows for a much safer operation and troubleshooting of machines or measuring of processes where you don't have to be near it or need any cables, because again, the camera could have a battery, be inside, and you have a wireless tablet. And just like with our FastTech cameras, all of the high-speed settings are available. So complete control of the frame rate, the frame size, the lighting, and other things. There's a lot of other items we'll show you as well in a few slides on what else we can control in the camera. So.
Yeah, and just to give you an idea, here's the tablet, just to give you an idea of what that looks like. So we'll try to make it not become invisible with the backgrounds. But it's got a palm. So the idea is, as Sean mentioned, this is it. It's totally wireless. It's controlling the camera as is, and so we're tapping into the fast motion software to allow that portability. So you can imagine you walk out as you've seen in the pictures with this, the MX has a sort of handle on it. You pick it up. This is around your neck. It's wireless, and you can go out with maybe a single LED lens or light if you wanted to, or and all this is something you can just pick up and walk out, set up in the matter of just a couple minutes and be recording. So that's kind of how that works, and how sort of that portability option really comes into play with this really streamlined workflow.
You thing, of course, that also will control it, but the portability side, the tablet really makes it easy to use. So very touch friendly. We spoke a little bit about the video trigger, and this is an example of a video that was shot with a video trigger. So you can see the little red box that's on the screen, and what that box is it was looking for that arrow to pierce that portion of the video. And when it did, we allocated some pre-trigger time, so we armed the camera and said, when an event occurs that crosses this threshold, let's start recording. But I started recording in a 300 milliseconds before, or whatever time was necessary. That's adjustable. And it allows you to use motion-based events to actually start triggers. And this motion trigger can be stretched to be the whole length of the screen, or everywhere you need it, and allows you to actually use things that are happening in the screen on your machines to actually trigger and start a video, which is very convenient.
Yeah, and I can kind of show that a little bit here, just to bring up the FastTech software. You can turn that trigger on and off, really simple. You can see it here, and you can extend that. So, as Sean mentioned, if you wanted to put this to where capture something falling, or you wanted to stretch this vertical, anything that moves through that emotion event would trigger it. So you can, if there's a very demanding event, or just sheer convenience, to be able to use these video triggers, you can do that, and that's available sort of in the on the desktop if you are connected via Ethernet, or on the tablet too. You can set it up on the tablet as well.
It allows you to do things like, let's say you're at a bottle plant and a bottle falls, the bottle could trigger the video to start, and you could go back and say, hey, now I want to do MA on what happened with the machine that made the bottle fall. And there's no way to set up a digital mechanical trigger for that without a bunch of other sensors. And so it's now built into the system. So for troubleshooting on the video domain, there's new tools in the toolbox to allow you to actually do that. So longer record times hinted at these as well. And All of these frame rates that are shown on here can be streamed directly to the SSD for long record. So if you look at the top one, for instance, if we stream at full resolution, we have 12.5 minutes we can stream directly to the 1 TB SSD, which is a really long, really fast file, but it allows you, as you can see, if you look through the whole table, depending on frame rate, what we can actually stream directly to the SSD. And the beauty of this is it just means, again, if you're doing a route-based or something, we're not going to run out of time as you go through. You can make all your measurements, come back and do analysis. Or if you have a long event, you can still grab that event. Maybe you're going to grab that event and have a few triggers in between that fire into the camera so we can keep track of events and analyze them. But it allows you to take data very quickly, but still streaming it to an SSD for post-analysis. And it's dual purpose now. So in the past, you bought an MX and probably used it solely for the purpose you purchased it for. But in this case, the Iris MX also works completely as a high-speed camera, allowing you to maybe share budgets with other groups of the plant or every other areas within your company where maybe some high-speed video would be useful. So you can use it, of course, as Jeff showed, the motion amplification still works intrinsically great with the Iris MX, but we also can just record high-speed video. So like the arrow that was piercing the balloon or any other event that may happen in your facility, we can just record high-speed video and you can watch it back. Of course, now you have the beauty of watching it back or saying, hey, I saw something that happened. Maybe I want to do motion amplification on a port of it, which sort of brings MA and engineering and troubleshooting together in a really strong way. And the software, the full fast motion software suite is included with the system.
So one thing I was just going to demonstrate too, I think it's worth noting on to show the sort of the speed up on it for those, especially those of you have used the MX in the past. Sean mentioned the image memory is 32 gigabytes. I wanted to kind of show how fast the save times are on this. So I'll just do a 32 gigabyte sort of recording. And then I've also set the settings to where they're, a typical MX, 720 HD setting with 1400 frames per second. So I'm going to set this up to where we are going to record the entire time here. So let's do that. And then we'll arm this and then we'll trigger. And so now we're going to record, 32 gigabytes worth of 32 gigabytes worth of data. So it'll just take a second, and then I'm going to save it. And I wanted to kind of demonstrate how fast this workflow could be, because the reality is that you literally now can just set this camera down, record, and then essentially walk away when you're done. Because if I go to save the video file, I'm going to save it to the internal SSD, and that's how fast you can save 32 gigs worth of data. So now, and you can pick it up and be walking to your next shot, right? You're not losing any time during this A process. So again, think about using this as, even at the 120 frames per second or at the high speed. The workflow is not a limitation in any way in terms of speed.
A little bit on the fast motion camera control app that's also included. This runs locally on the camera controller. So part of the MX includes a full Linux-based machine that controls the camera, and it's embedded, and that's how the tablet, of course, can control it. And it can control it via wired or wireless connection. This software also allows you to control multiple cameras. And so if you had 3 MXs on all sides of a machine or whatever you'd like to do in that domain, you can surely control them all with fast motion. It manages multiple record modes. So whether you want to record to the RAM, to the SSD, in what file format, and so on, you can actually change that all in the system. There's lots of video playback and editing controls. It allows you to set up all of the input and outputs that we described earlier. One of those, which is very interesting too, is to synchronize with strobe lights or other lighting. So that's all built into the system. So instead of having really big, expensive DC lights that illuminate everything, you can actually use a controlled strobe and control it with the camera and take data, you know, at really high speeds and still have enough light. Goes, complete integration. And there is an SDK, on the vision side, if someone in your corporation is interested in just having a high-speed camera, that allows custom integration. So you can add third-party applications and other things to the camera.
And one thing that's also interesting is we mentioned the I/O ports on the side, then the video-based trigger. So you can, if you wanted multiple MXs to capture a single event, you can synchronize those. But you could have one camera set up a video trigger of seeing an event. Maybe it's on, one part of the machine, but you need to film another part of the machine that's not going to see that event. The video-based trigger can fire and tell the other camera they're synchronized. It will also start the acquisition of the second camera and keeping that synchronization. So you can export a trigger essentially through those cameras, which is really nice. And again, we had talked about Tom's webinar tomorrow. It's going to cover this stuff and more. So if you're interested in the high speed aspect, leveraging an MX on the high speed and how you can sort of utilize it in your facility in more ways than just what you traditionally thought of, definitely check that out.
Another big advantage with the MX over the M is the larger field of view due to its large sensor size. So the camera has a larger sensor, which allows you to see more. So if you look at the screen, you can see the classic view of the Iris M. If we had the same standoff, same lensing, same everything else, but then you can see what the MX would see. So you can get a much bigger picture right from the get-go, which quite regularly is helpful. So I know a lot of times you're always reaching for a wider angle lens on the M. Naturally, the MX already has that wider angle built in, basically. So it amplifies the angle you get, giving you a larger field of view of what you can look at and what you can analyze. So a few little datas at higher speed, a couple of videos. So this is a pump at 246 hertz or so, 247. And it shows, the motion amplification that we're seeing there is obviously some problems with the pipe. And of course here after mods, you can see it's fixed. And this classically, of course, would be impossible with the IRIS-M because the frequency is too high for the IRIS-M to see it with that sort of field of view. Where in a single shot with the MX, it's no problem to see, resolve, understand, and of course, work, help you outline what you'd need to fix it. You can see the great difference between the pre-mods and the post-mods. Most of that pipe motion goes completely away. And of course, that's what we're looking for in applying these fixes. So it's a real neat way of doing higher frequency work. And again, you saw multiple different views here of this pump. That means you could have taken that MX, put it in a few different places, recorded, and gone back to your desk and done that analysis. You could also use the same workflow where you're doing it in real time, right at the pump as well. So with the full kit. So same, wanted to share a little information also on a motor compressor. In this case, the motor is, running at 50 hertz or so, but the compressor at 200 or just under. And you can actually see that motion, because we're using an MX. Again, taking frame rates of higher than 500 frames per second allows us to really see motion you couldn't see just with the IRIS-M. And see this imbalance and the flex, all the accessories moving, things that just couldn't be done with the standard IRIS-M. And of course, obviously, again, when you can just carry the camera on, not have to worry about the computer, all the cabling, connecting everything, running AC power, it's much more convenient now to do this with the MX and walk around than it's ever been in the past. So there's a QR code right on the screen that goes straight to our contact page. It allows you to send us a question. See that no one's asked any questions in the Q&A section yet. We'd be, of course, glad to answer them both, here or privately afterwards. So if you have any questions, please, scan the QR, let us know what we can do.
Yeah, and as you were mentioning that, one thing I I also think is interesting is the and you talked a little bit about it, Sean, the I/O ports and the options for saving data. So it's really flexible in that, you know, with the MX you can choose to save data to the SSD that's in the camera. You can choose to save the data through RDI acquisition directly to your device. But there's also an option. The workflow of the speed of the downloads is sort of all the way through the system, in that there are on the side there's Thunderbolt ports that you can get a Thunderbolt drive. For example, you get a 4 TB Thunderbolt drive and plug that in, and you could either save directly to the drive, or save it to the camera and then save to the drive. So it's sort of an interesting workflow in that when you go out and do this really rapid data collection, everything could end up on a just an external drive, that's really small, that you could either take with you, depending on the way you use this, back to the office, back to your, if you leave the site, your service provider, take it with you. So there's a lot of flexibility in the way that you can transport your data, save your data, and utilize it in that way. So that's, I think one of the things that's exciting about this product is the flexibility that it affords in sort of your improved workflow. Okay, well, if there's no questions, feel free to reach out. You can connect with us on LinkedIn, go to the website, scan the QR code. Lots of ways to connect, but definitely, if you have any questions, don't hesitate to reach out. And if you want to learn more about the MX, and you want to do something more, sort of one-on-one, or set up a call to go over your applications to see if it's suitable for your use, or just learn a little bit more about how you could leverage in your facility for the high-speed option, we'd be definitely be interested in chatting about that. So feel free to reach out.
And a copy of the recording will be available shortly after we finish here. Probably take an hour or so to download. Thank you.
Thanks, everybody.
Thank you.